Alright, time for another dryphysics.com video presentation. I should be showing up shortly. Oh, there I am. Alright, so update video sort of, and we'll go over a list. Every now and then I write up a list, attempt to consolidate the argument and try to make it pointier so we can get through your thick hide of a brain. So you get the obvious point being made that's just so obvious to me, and somehow it's so obscure to you that you can't even see the glimmer of truth. You can't see any possibility. Come on, it's just too ridiculous. But anyway, I mean, you won't concede anything. Like, oh gee, I wish we had more evidence. You can't even say that. You pieces of shit. You can't even concede, oh, I wish there was more evidence. I wish physicists over the last 300 years had done a few of these experiments to prove this shit decisively, instead of just this wishy-washy, oh, in the 1700s, we dropped some round things into clay. There, we've done our job. It's all proven. I mean, come on, it is pathetic. I mean, you're making kind of a bold claim. It takes 4 times more fuel to go twice as fast. In any circumstance, it takes 4 times the energy to push something twice as fast. That's a bold assertion. You think it would come with some kind of physical evidence somewhere? Come on. No, you won't concede. So I mean, that just proves that you just have no sincerity in this conversation at all. Speaking of sincerity, I would argue I'm being completely sincere in the whole thing I've done over the last 10 years of dissecting this really pitifully stupid physics. I have no insincere agenda besides my own surprise that it is this broken and this obviously deficient. Obviously, these models don't work. It is crap. This whole Weaverse bullshit is just silly. You can't draw a picture of any of it. It's a nonsense. And there's nothing insincere about that opinion. It's sincerely, every bit of my neurology says, boy, this is like obvious. It's obvious that it's crap based on mush. This isn't good science. It's not convincing. It's as bad. It's as rubbish an argument as any other religious theory. It's full of whatever, shrouds of Turin, clouds of woollycols. I mean, it's just, anyway. Alright, so I have made a couple of videos on the website, just to point out anyway. Mindless Marbles one, which, it's kind of tedious and redundant, so I don't know if that's too good, but the one on kinetic energy is pretty good. It's like only 15 minutes, kind of tries to point the argument, blah, 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 so you probably should watch that one if you're not paying attention to the website videos. Then there are a couple of live videos I've done if you haven't watched the live videos, but again, it's a lot of wasted time arguing with assholes. Speaking of which, just for the sake of the argument, I mean, I will unblock somebody I have blocked if you send me an email and politely request, and you're not notoriously evil. I mean, I'm not going to unblock you if you've posted my personal address in the past or done some other kind of crap. Yeah, you're not getting unblocked. All right. But if all you've done is, say something a bit offensive to me, or, made some personal attack, or done something else to piss me the fuck off, fine, you can request. And, the idea is if, okay, you've gone to the trouble to send the email to request being unblocked, I'll unblock you. But I'm going to block you again if you just go back to the same bad behavior. I won't be lied about. I'm just saying I have no obligation to defend myself against jackasses who think all they have to do is make up a lie and state it and then force me to defend myself. I'm not going to do that. Not on purpose. Alright. Not when there's tools to stop me from having to do that. I'm going to use them. So if you can't premise your argument with some kind of factual, reasonable statements regarding what I'm doing and what I've said, then fuck you. Anyway, So, yeah, I guess that covers that. So we'll just get to the arguments at hand. All right, so I just wrote this little bit of slop. All right, reasons not to believe, right? So that's all. I'm just saying there's lots of reasons, in my opinion, to understand that momentum always works and it's really good stuff. These are the reasons not to believe in 1/2 mv squared, okay? And the biggest reason is there's just no physical experimental evidence. Nothing. All right, now I've already been through the stupid little clay experiments. I've explained how dropping round things is cheating. Okay, unless the round things both go past the halfway point. Well, it has to be kind of a bit past that. Because obviously round things have different surfaces. Some of the surfaces have a lot of this, and then some of the surfaces have a lot of this. And that makes a difference in how you have to push the clay or whatever you're penetrating. So I'm just making the argument that obviously how you point something will change how far it goes through something. So I think every one of you could understand that I could use the same energy with a stick, and I could poke it into something, and it's going to go further if I have a point on the stick than if I don't have a point on the stick. So how far it goes into an object really doesn't say much about how much actual energy I'm applying. So it would be kind of silly not to recognize that it matters the shape of the object. And that's all they have. Okay, so outside of that clay experiment in 1735 or whatever, they don't have anything. They can't show you any physical evidence of this 4 times the energy or 8 times the energy or 1,000 times the energy in the case of the bullet. They say the bullet moves 1,000 times more pieces of material atomic substance. They say that's what it does. Now, I would make the simple argument that no, it moves a lot of stuff in one little tiny area, okay, but it doesn't move as a total the same number of atoms, or 1,000 times more atoms than the recoil of the gun. That the gun is moving much more mass, and therefore, obviously, the gun doesn't have the same penetrating power. So again, it's another argument that's almost as simple as the argument for how you shape something. The speed does matter in the sense that if I throw something, I shoot a bowling pin with a bullet, that bowling pin is going to absorb a lot of energy, okay, more than it would absorb if I hit it with a bowling ball. But the point is the bullet's going to lose a lot of energy also, a lot of energy, half its energy or more. And so that's the difference, and you're really just saying what's the total amount of energy, and these really shouldn't be complicated conversations. But the fact that the physical experiments just don't exist is just a fact, and it should be acknowledged by honest people that, oh, this really should have been done. Hundreds of years ago, in fact, this should have been sewn up tight, regarding having physical evidence for a theory, a formula. Formulas should be backed up by evidence. They shouldn't be just written down and everybody just prays to it. That's religion. All right. So these are the specific kind of arguments regarding this lack of evidence. So it's a kind of a bold statement. Okay, 4 times the fuel to go twice as fast. So in any circumstance where I give an object, this velocity versus that velocity, twice as fast, every single time I make something go twice as fast, the theory, conventional physics believes, all of these mathematicians and all these high degree doctors of this and doctors of that, they all are defending a theory that says it takes 4 times energy to go twice as fast. 4 times. And yet you don't have any evidence in your life. It doesn't take 4 times the gas to go 60 miles an hour than 30 miles an hour in your life. Lawnmowers. I can bring up every kind of engine, every kind of device, and there's just no way to defend this nonsense. We could go to the Hoover Dam, right? We could watch the turbines, okay? And we could find out that making the turbine go twice as fast doesn't make 4 times the electricity. This doesn't work. It doesn't happen. It doesn't happen in this physical universe that you move something twice as fast that has 4 times the energy. So this should be a glaring fact where you just say, come on, okay, they have absolutely, and all the things moving on this planet, all the things we make move, they can't show us any single piece of evidence demonstrating that it takes 4 times the fuel to go twice as fast. Not one single piece of physical evidence. And you are unimpressed by that fact. That fact means nothing to you. It's not important to you that you have no evidence backing the theory you're claiming. None. You're just stating it and defending it and asserting it, and you can't demonstrate it with a single piece of physical evidence. That doesn't impress you. It surprises the hell out of me. Okay, yeah. It seems inconsistent that I would believe you are sincere, devotees of truth, chasers of the truth, if that fact doesn't bug the fuck out of you. All right. Good evidence gravity is about time, not distance traveled. Now, there's really good evidence, and I've drawn the evidence, and I've stated the evidence, and it's a good piece of evidence that you can look at gravity lots of different ways. I have lots of different examples of how it works, and you'll find that it's all about time. So I could do the simple one where we just drop something straight. All right, a little bit of glare, but it'll be all right. And I can drop it from 4 times the height, okay, but it'll only weigh twice as much. So it's 2x the weight. All right, so even though it went 4 times the height and only 2x the weight, I could sort of just point out that I could just take, one mass objects, okay, the same mass object I put up here, and I could take 2 of them and just raise them just to this point, just 2 notches of distance, and I can make it weigh the same amount as this 4. 4 units of distance weighs the same as just 2 units of distance. You see, okay, yeah, that's an obvious glaring fact. There's no way to avoid that. All right, and then the whole thing depends on this idea that this is 1 unit of time and this whole part here is 1 unit of time. And so it's in the gravity, it's getting pushed by gravity, only these 2 units of time. So that's the key thing to understand, that that's all there are. There's just 2 units of time having gravity affect you. All right, and if I went another one, it would be a big giant 5 here. Okay, so as you go faster and faster through gravity, you're less and less affected by it. Gravity can only affect you while you're in it. So I've used this simple example of a gravitational body, and you can understand it has a range of relevant gravity that would be a certain range of distance, a certain distance that the gravity has some real power. And that if you fly by really fast, you're only going to be affected by a much shorter period of time. And so it's almost like a paint sprayer. You could just argue that the gravity is like a paint sprayer. And the faster you go through it, the less it's going to bend you. And this works perfectly. This model perfectly explains how gravity affects an object. And the slower you go, obviously the more effect there's going to be, because you're taking more time. And the more time means it has more painted, more pressure is put on you, and you'll crash into the object. So it's not about this distance. This distance isn't telling you anything. What's telling you something is how much time is it. I really do have to fix that. That is way too glary. And then the video will probably crash, and blah, 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 blah. All right. Okay. It appears to still be alive. Good. It's better. Not perfect, but it'll have to do for now. So I'm not going to go fixing everything. Anyway. So, I mean, it's a valid argument. It's a good model to understand that really if you shoot something into gravity, that it's really the faster you go, the less it tends to bend down towards the earth. The higher the velocity you give it, the further you'll go before it will have the ability to push you into the earth. It makes perfectly good sense to understand gravity as a force collected over time. It's a completely time-dependent force. Distance isn't telling you anything. Time is telling you everything. All right. Perfectly sensible, reasonable argument. No one should be called an idiot for making such an argument. It's really a pretty damn good, solid argument. Okay. Good evidence gravity is about time, not distance traveled. Okay. Throwing lighter things does not make more energy. So that's the theory, basically, because of the v squared. Any time, all right, you increase the velocity, okay, and especially increase the velocity by decreasing the amount of weight you have to throw. So you're throwing a shot put, and I make it twice as light. There's obviously now you're going to be able to throw it faster. And their theory is because of that increased velocity, somehow I'm exponentially increasing the energy. The energy is growing more than double. And so no matter how much I reduce, for every little bit of atoms I take out of the shot put, make it lighter, somehow, okay, now you will throw it further because you have higher velocity, and somehow it's going to land on Earth with more energy, by this squared term. So if I can get it all the way down to just one atom, and I can throw it proportionally fast enough, I can create millions of times more energy. I can take the same throwing arm, and I can make it millions of times, okay, more explosive. And you have to understand that's just silly. That if I thought of the shot put as a bunch of sand, that there's no way that if I change the equation from throwing 1,000 pieces of sand to just throwing one piece of sand, that somehow now the energy I'm going to use to throw that one piece of sand or move it is now 1,000,000 times more energy. Same energy, and somehow I have an output that's 1,000,000 times more. So it's back to the gun and the bullet example. I won't even draw this one because it's so simple, right? I mean, the bullet and the gun, by Newton's laws, you're basically saying equal and opposite reactions, theoretically, at least pretty close to. The gun's recoil will be essentially the same mass momentum as the bullet. And so how do you make any sense of saying that the bullet has 1,000 times more energy? Doesn't make any sense. It won't, in fact, move more physical matter in the universe. It doesn't have... Momentum is your energy to give. When a bowling ball hits pins, it loses its momentum to the pins. It gives them its energy. That's the way it works. It can only give them what it has. The bullet doesn't have more energy. It just has fewer atoms moving faster. So it will give away its energy quicker. So that'll look impressive because all its energy hits a place and all of it goes in 1 millisecond. And the gun, because it's moving slower, will give its energy slowly. But it's going to be more atoms. It's going to move more atoms slower. The bullet's going to move fewer atoms faster. Yes, those things will look different, but you can understand the physics, and the physics says don't go by what it looks like. That's a sucker's paradise. Think a little bit about what actually happens. That's what a physicist should say. All right. 4 times the height is only twice the velocity, twice the time, and twice the weight. It seems a gigantically obvious argument to make. All those twices, all those twos, twice the velocity, twice the time, twice the weight. Why would I think that has 4 times the energy? I mean, it doesn't make any sense. So it's not mgh as a formula, it's mgt. It's just about the time. 4 times the height only gets you twice the time in the gravity. Gravity only has twice the time to work on the object, to pound on it, to push it. If gravity is only pushing for twice the time at a constant big G rate, then obviously there can only be twice the energy in the object. It's only had twice the time to collect it. There's only, if I have a bucket in the rain and I let the rain fall into the bucket and for 1 second, and then I say, okay, I'm going to leave the bucket out for 2 seconds, it's going to collect twice as much water. And gravity works exactly that way. Every piece of evidence, it works all the time. You can't give me a scenario where that simple analogy doesn't work. Gravity is spraying the force on you. It's right now pushing you into the earth, giving you a velocity into the earth. You are in fact moving into the earth. The trick is the earth pushes you back up so you don't gain any velocity in the direction because you keep going backwards. For every forward step, it pushes you back. You forward step, it pushes you back. Doesn't change that. It's doing it all the time. So you are in fact moving down. It's just that the earth keeps pushing you back. Duh. But you have a real momentum. That's causing your weight. That's causing your mass to be able to deflect the spring put in between you and the earth. It's showing you that you are in fact going into the earth. Alright, gravitational friction does not take the same energy regardless of speed. So this is I'll probably draw this one just because this is another good example where you can really understand it if you're at all honest. You take any of this science seriously. If you really care to take this science seriously, it tells you that this is where you get fooled by little things that should fool children but shouldn't fool adults. Grown-ups shouldn't be fooled by this this little visual effect. Alright, so you can you can test something's energy with a kind of a silly, okay? I mean, it's a superficially sensible experiment. Okay, I move this thing twice as fast. I give it twice the velocity. Alright, so this one has one velocity, this one has twice the velocity. And then I let them roll down a surface, right? And this one will go 4 times faster, okay? I mean farther than this one. This one will only do this, okay? It goes from here to here. This one goes all the way over here. And so yeah, you look at that and you say, gee, that's so obvious. This must have 4 times the energy. Look, it went 4 times further. It's incredible. Look at that, 4 times. I mean, it's 4 times further. It's not a little bit further. It's a lot further. It's not twice as far. It's 4 times further. It's got to be 4 times the energy. Yeah, okay. But that's, that's not physics. Physics is analyzing that and understanding that, yes, well, what it does here is the same time. Okay, so this last unit of distance it does, right? This unit of distance is the same time as this unit of distance. And this whole thing here, okay, because of the higher velocity, is the same time. So it doesn't go half the speed until it gets here. Here's where it's going half as fast. All the way back here, okay, all the way down this last bit of distance. The last chunk of distance is the same as this. So this energy is the same as this energy. And the fact is, this energy is the same as that energy. This is only going twice as fast. This here, this big giant swoop, because you could sort of understand it's going fast. So the gravity isn't pushing it into the friction. It's not getting pushed down as much because it's zooming through this distance. So per foot, it's giving little tiny bits of energy to the ground, where this one per foot is giving big hunks of energy to the ground because it's moving slowly and it's really getting pushed into the ground. So you can understand it very simply. This is very little paint hitting the speeding bullet, so to speak. And it's not until it reaches this point that the rate at which the two objects are getting pushed by gravity or getting paint put on them is the same amount of paint. This is the same amount of paint as this. And this whole hunk is the same amount as that. Even though it doesn't look like it, that's all the paint it collected because it was moving really fast. So this collected the same amount of paint as that. This collected the same amount of paint as that. And the fact is, this is just twice as much paint. It's not 4 times. This is only twice as much energy as this. It doesn't look like it because it goes 4 times further, but it goes 4 times further because the friction isn't fair. The friction isn't the same here, or here, or here. And it doesn't become the same until you get here, where it gets to be, the first bit of friction is an arrow. Say we analyze just this. The first bit is a big piece of, a little piece of friction, right? As it goes slower and slower, right? Now it's slowing down a little bit and it loses a little more and it loses a lot more. And the slower it goes, the more it's losing to the friction, right? The more every bit of its energy is getting sucked out of it. So that's how gravity works. It isn't every single inch is the same exact energy going into the ground. You're not heating the ground the same amount with each roll. Every roll is distributing a different amount of heat depending on how fast you're going. The slower you're going, the more you push into the ground, the more contact you have with the ground, the more you can move the ground. That's the simple explanation. It's not very complicated, but that's the scientific explanation. The unscientific thing is to say, it looks like 4x, like it looks like a wave, it looks like, well, no. Looks like isn't necessarily is like, and scientists should be able to do what I just did here, which is you think about it and you say, well, this is a proof right here. The fact that it's only going half the speed after it went 3/4 the distance, well, that's sort of a giveaway. That obviously the friction is not even. Yeah. Not difficult, frankly. Not a difficult argument to understand. No one will refute it because it's just unrefutable fact. That's exactly how it works. That model fits perfectly. All right. The efficient momentum transferring function of levers. So I'm just arguing that, yes, levers are able to transfer momentum. And they can transfer it between objects that have uneven masses. That is, big M's and little v can be converted into a big V and a little m. And it can be done so very efficiently. So unlike a Newton's cradle that fails to be able to take a big slow object and convert it into a fast little object, a lever can do the job. Okay. Proves the kinetic energy theory unviable. So clearly the lever can do the conversion and it's quite efficient and momentum is perfectly conserved, and you end up with the ludicrous result that you end up with, free energy. That every time I use a lever to convert a big M and a little v into a big V and a little m, I make free energy. And every time I take a light object going fast, a big V and a little m, and convert it into a big M and a little v, I lose tons and tons of energy, proving it's nonsense, because I'm not losing energy. The lever works, the balance works, the scale works. Okay, it's efficiently transferring the energy, like a spring or some other devices that are also capable of doing the conversion. Springs can absorb energy very slowly. I can press this spring down really slowly, okay, and leave it at a point, and that's how much energy it has, 5 pounds, let's say. And it can give it back fast, or it can give it back slow. So springs can also do the conversion from fast thing, okay, light fast thing, creating a weight. Drop a light thing very far, it creates a weight. I can drop a heavy thing not so far, it creates a weight. And I can convert the two. Alright, but levers do it even better. Levers are even more efficient than springs, I would argue. But regardless, they're both capable of doing the job. And because they can do the job, they prove the kinetic energy theory can't be the truth, because the momentum is perfectly conserved and the kinetic energy numbers go all kinds of crazy. The simple truth is, I guess I should write it down here as one of the points. 5-ton trains going 10 miles an hour have the same energy as 10-ton trains going 10-ton trains going 5 miles an hour have the same energy as 5-ton trains going 10 miles an hour. If they were in a tug of war, no one would win. Okay, it's just a fact. They have the same energy. You can use one to create the other by using a spring or using a lever or using some other energy storage device. They'll both produce, if I put a generator on their wheels, they'll produce the same amount of wattage of electricity. They'll create the same energy, the same heat. Now, obviously, because of the speed, the 5-ton train will give away its energy more quickly. If it hits a cow, it'll give the cow more energy, but it'll also lose more energy to the cow. Its total momentum will go down faster than the 10-ton train, but the total capacity to move matter in the universe is identical. All right. So as a Lever proves the kinetic energy theorem unviable as fact. That's not written very well. Unviable as fact. Okay, comma. As levers would produce free energy. And obviously there isn't any free energy. It's just a silly idea. All right. It doesn't take 4 times the spring compression to move an object twice as fast. So this is another one where, come on, you've got to know that's, you don't bang, so you don't have something go twice as fast, hit a spring and compress the spring 4 times as much. Okay, it doesn't happen in gravity for sure, but obviously every time you'll test it, you won't see it on a scale. The scale won't show it to be true that it's 4 times the energy. So sometimes you have to say, somehow you have to say scales aren't measuring energy or impact or pressure or anything that you could rationally associate with energy. And energy is some sort of sparkly, magical thing that doesn't have any real substance. I mean, that's just nonsense. What's the point? If that's going to be your underlying theory, that we're not talking about something real in the universe, a capacity to move matter, well, this measures your capacity to move matter. That's what this scale is telling you, is how much matter can you move. And that's perfectly consistent with Einstein's argument that, mass is energy. All right. It says as fast, nor does an object moving twice as fast compress the spring 4 times as much. So I just did sort of the compress the spring 4 times as much argument. But do you really think that if I, if I compress the spring 4 times as much, the object leaving is only going to leave twice as fast? I mean, it's a ludicrous proposition. Complete nonsense. Not even close to the truth. The observable truth. Now, yes, I can't show you a whole bunch of experiments because no physicist does these experiments. But I certainly could do them in a crude manner and show you that if I compress this thing twice as much and launch an object, it'll only go twice as fast. Okay, maybe a little less because there's some losses, but certainly if I go 4 times as much, it's not going to go just twice as fast. It's going to go 3 or 4 times as fast, clearly. It's just nonsense to believe otherwise for no reason. Again, you have no physical evidence you can show me of anybody ever compressing this thing 4 times as much and only getting twice the velocity out. That doesn't happen. Nor the opposite, something going twice the speed into the scale and compressing it 4 times as much. I can't make this do that. I can't bang something into this at twice the speed and get it to push in 4 times as much. It just doesn't, and it won't happen. It's a silly thing to believe. It's frankly silly. Now, okay, you haven't really thought about it. You didn't research any of this stuff. You didn't think about it. You're just defending a bunch of archaic ideas that physicists had in the past, and you're saying it's all somehow it's a valid story. But what's the difference between you doing that and somebody defending the Jesus fable? They're basically saying, well, all my scientists said so, and all the great people in the past said so. A bunch of really smart people 1,000 years ago said so. So the only thing you're doing that's different is you're saying somebody 200 years ago said so. And therefore it's true. You don't have any evidence. They don't show you any physical evidence. They don't show you any proof. You're just believing because, well, I believe in them. Yeah, that's not science. All right, only momentum moves objects in the vacuum of space. So I made this argument. I mean, NASA even admits, we just use Newtonian mechanics. I mean, they're basically conceding they're not using, Einstein's crap or Leibniz's crap. Okay, they're not using the modern physics because it has no role, because the simple truth is it's just about moving masses velocity. You move a mass with a velocity, you have energy. And that's what thrust is. Thrust is moving little tiny masses at a velocity. And if you can move stuff, if you can let stuff go, like you have a vessel, and if you can let stuff leave that's going that way, then you're going to end up going this way because you're going to have a difference in your balance. The pressure is the things going this way are still hitting you. The stuff going that way you let out. So you're obviously going to go that way. The simple balloon illustrates the point. But that's how the vacuum of space works. That's how space works, is the energy has to be real. And so if I did have a space shuttle and I could shoot a bullet out one side and I could let the recoil of the gun fly out the other side, The fact is, in two different experiments, of course, the bullet has as much turning power as the recoiling gun. I'm not going to gain more thrust by letting the gun fly out than I would letting the bullet fly out. The bullet's 2,000 joules. The gun only has 2 joules. Well, those numbers won't mean anything, because all that's going to mean something is how much mass is it and how fast is it going. And that total number is going to decide how much thrust, how much energy I have released to the universe. The universe knows that your 1/2 mv squared crap doesn't mean anything. Momentum means something to the universe. All right, I'm asked, given a velocity equals a weight. A weight is energy. So again, I can just make the, it's so obvious, right? I mean, I'm in space, away from all gravitational influences, me and my scale. I put my scale here, I don't weigh anything. I put my scale here, I don't weigh anything. I put my scale over here, I don't weigh anything. I have to give myself a velocity before the scale says I weigh something. And obviously, if I don't have anything to put the scale on, right, it's not on an earth or a surface holding it in a position, well, then the scale's going to move and I'm going to move, right? The spring is going to collect our differential and then it's going to spread our differential both ways. But the simple truth, I don't weigh anything until I have a velocity. You don't weigh anything. Your mass doesn't have any weight until you give it a velocity, until you push it with momentum, with velocity, movement. So without the movement, you don't have any weight. And it's the combination of weight and movement that is energy. And that's what weight is. This is an energy detector. Okay? One of the really great energy detectors invented by humankind. Right here in front, this little simple device. Great energy detector. All right. And levers are great energy converters. And again, this is... I have to be a little, I can't not insult your intelligence in some respects because you're not applying any intelligence. You're not making a reasonable counter argument. You're not countering any of these arguments. You're not explaining how this fake energy means anything. Now, I guess I should add here, okay, that this whole thing was initiated by a religious kook who wanted the universe to look more like a God created it. That was his ambition. He had appreciation that God was looking like you didn't need a God. He complained that Descartes was an atheist. Okay, he was a Jesuit, but he complained that Descartes' physics was too atheist. He was afraid that Newton was too atheist. All right, so I said, these were overt statements he made, and he invented this. Well, let's just square the velocity. Okay, in the MV formula. So right before Newton published his extensive, description of how the universe functions, Leibniz proposed this crap. All right, and it was resoundingly defeated because Newton got so many right answers. Newton predicted so many things, and the whole mechanics worked so well. And then they dug it up in 1735 and did the silly little clay experiments, which are just sort of like the rolling the ball thing. They fooled people with really, experiments that are easily dissected and easily explained why the illusion exists. The illusion of greater energy because it rolls further. Well, it rolls further for reasons, and you can understand the reasons. And it has nothing to do with the object having more energy. It has to do with the fact that friction is not an equal player. It hurts slow things a lot more than it hurts fast things. Just a fact. All right, so that's all I can do is attempt to reason with you, but I'm just saying it's a bad theory historically. It's way under evidence. I mean, preposterously under evidence. And I can give you all these logical reasons to understand that the things you know of in the universe are completely, the things, mechanical things you can trust that are reliable are completely inconsistent with your theory. They don't work if your theory is true. okay, including lunar modules landing on moons. They don't work if I use 1/2 mv squared to calculate how much thrust to use. Your theory would fail to land successfully on the moon. All right. Okay. So it's your, again, there's a point where you're just belligerently hostile to the truth. The facts are numerous and unrefutable, and it's time to just concede that you should at minimum concede you want more evidence, you want more experiments, you want some sort of decisive proof. You should at least be able to say we're lacking evidence, and that you really don't have any authority to tell somebody else they have to believe in 1/2 mv squared because you can't defend it with evidence. And that should matter to you. You shouldn't be proselytizing for some remedy. Okay? You're just a snake oiler, right? You're just selling a product, and the product could be killing people's neurons. You're just, that makes you sort of evil, right? You're breaking people's brains with your propaganda. So until you have some evidence and some sort of integrity to your arguments, you really shouldn't keep just defending it because everybody else says so. That's about as lame an excuse for saying something as there is. Donald told me so. Is that, what's Biden's first name? I don't even remember. Lord Biden. He told me so. That works for you? Oh, fuck. People are pathetic. Alright, so anyway. That's it. Yeah, that's it. So all I'm attempting to do here is reason with you people. I've done the research. I've picked at this stuff. I've played with it. I've messed with it. I've gone out and looked for the evidence. And I'm telling you, if you do that, you won't have any other conclusion that, holy shit, this is just a fable. There's just no good reason. There is no good reason to believe in 1/2 mv squared. There just isn't a single good reason. You have two silly little experiments where you're rolling a ball and pretending you don't understand how friction works, or you drop things, of different shapes into clay and pretend you don't understand that how it's shaped will change how far it goes into the clay. Alright. But that's it. You have no good reason to believe, no good reason to promote, no good reason to aggressively, extort people into believing. No good reason. Just bad reasons. Alright. So stop being bad. Simple enough statement. Alright, so this has been another draftphysics.com video presentation to people who just don't care, obviously, about the truth. Sadly. Don't wish to do it honor. Hey, I'm disappearing. What the fuck? Oh, I understand why. Yeah, that's right. Yes, I think about it a little bit. I can figure out, that's just an illusion. Yeah, it's just a video. Okay, yeah, I didn't really disappear. Come on. You people can be smarter than you're behaving. Alright, till the next time and such.